technology. So you name a field, and there are applications in R to do different analysis. Okay. So we'll briefly talk about what R is, and then we'll talk about the different data types and data structures in R. Okay. So my aim in these 2 days is to introduce you to the basics of R, so that whenever you wish to carry out any data analysis or learn more about R for data analysis, you'll already be knowing or having some information on the absolute basics of R. Okay. So data analysis, if you look at in today's age, is basically divided into, or the softwares that are used for data analysis are broadly divided into three different types. Okay, so you have something such as a command line based software, where you have to basically type in different codes to get certain outputs. You have something called as a GUI based data analytical software, where you have this point and click options, and the best example here is Excel. And you also have a hybrid type where you have options for both. So you also have a GUI based interface, and you also have the option of writing commands for analysis. So if you have seen this software called SPSS, so SPSS is a commonly used data analytical tool for GUI based, as a GUI based interface. So if you look at these different options, they are options for doing different types of analysis. So you just click on that analysis icon, and the software will do that analysis for you. Okay. This is a interface of how a command line software works. So if you look on the left hand side square, you'll see a bunch of codes being written, right? So these are codes that have been written, and on the right hand side you will see different values and plots. So the commands that you type will give you the necessary results on the right hand side. Okay. And in this context, what is R? So R is basically a language, a programming language, which has been specifically designed for statistical computing and graphics. Okay. So it has been designed to handle statistics, and it has been optimized to handle statistics, right? And it is something called as an object oriented programming language, where you basically create different objects. So you can imagine a result of an analysis as an object. So regression analysis. So regression analysis in R comes as an object, different object. Or a graph, say a bar plot, is an object. So everything in R is created as an object. Okay. And R is very interactive. So whatever commands you give, the associated results you will immediately see in the result window. Okay, so it's very interactive with that. So what does R entail? R entails writing different codes or scripts. Okay, so suppose you want to conduct or carry out t-tests or ANOVA, then you have to write a code to do that particular kind of analysis. Okay. So any analysis or any type of visualization that you can think of has a corresponding script. Now, to add that, there are different packages that have been written for R. Now, what are these packages? We'll look at them in just a few moments, but they basically add functionality to this R statistical language. Okay. So the R that you have downloaded, right, already comes with about 25 packages. Those are called as core packages. Okay. And R is also known to produce excellent visualization. So any graphs or plots that you can think of, with R you can basically create very customized and publication ready plots. And the most important thing about R is that it's open source, meaning you have access to any algorithm that has been written, and you can modify that algorithm as per your requirement. So Suppose you are doing a specific analysis for which there are no direct functions or there are no direct codes available. So what you can do is you can take the code that is already there, modify it for your research, and use it. This you cannot do with a paid software such as SPSS. So this is an advantage of R over such softwares. Now R is made up of different types of operators, okay? And we'll see some of those operators when we actually carry out the hands-on session. And these operators are used for different types of calculations. Okay, and you carry out these operations using something called as functions. All right. So what are these functions is, as I said, something we'll look at in the next few moments. So first, what are R packages? So R basically consists of core and add-on packages. Core is nothing but the 25 base packages that come with R. So if you install R, you will get those 25 packages. But sometimes what happens is your analysis is very specific. So suppose you are interested in analyzing GIS based data, or you are interested in handling protein based data. The core packages cannot handle all these data. So you need to install specialized set of codes which can handle those kinds of data or analyze those kind of data. So these functions are basically bundled into something called as a package. So each package contains a set of functions that you can use for specific kind of analysis. Meaning, suppose you're interested in importing an Excel file in R. Okay. So there is a package in R just to do that function, to import Excel files in R. Okay, so they are that exclusive in their functionality. So these are some of the examples. So you have a package called as Dippler just to handle data editing. You have a package called as ggplot2, which is extensively used for data visualization. So a package is quite specific as far as their functionality goes. Okay. Now, then what are R functions? So as I said, your main purpose of using R is to analyze your data, right? So you can analyze your data using a set of code written in a specific way, and this in R is called as function, right? Now every named function has three distinct components. So any function you see in R will always have these three components. The first part is the name. So you have to give a name to the function. So any function that you see in R will have a name. Okay. Then you have something called as a argument. Argument you can imagine to be the input data. Okay. And within curly brackets, you have something called as the body of the function. In the body, you are supposed to tell R what you want to do with the input data. So if you look at this example, this basically tells R that you want to add A plus B and return the result, whatever A plus B gives. You want to return that. Means you want the answer to this A plus B. Now, this is a very simple example of a functional, right? People write very complicated and complex functions also. And you can also write your own function. So in your analysis, if you come across a state where you don't have a function to do that particular kind of analysis, so you can write your own function for that, and R allows it. So since it's free, you can do anything that you want within R. All right, and R has functions for all common statistics. All common statistics. So any inferential statistical test that you can think of, R already has a function. So someone already has written a function for it. So as I said, R is object-oriented language. So how do you basically create these objects? You create these objects with the assign operator. Okay. So we talked about operators, right? So assign operator is this arrow. This is called as assign or assignment operator. Now, how do you read this? So if you look at this example, you have a variable, yeah, it's named x. What this tells is you are assigning the value 5 to this variable x, or x gets the value 5. And it's not only value, okay, you can assign anything to x. You can assign a function to x, you can assign a data visualization to x, you can assign data analysis to x. Since x is a variable, it can take in any values, okay. And our script then can be thought of as a way to make these objects, different types of objects, okay. Now R has different types of data, and based on these data types you have different data structures. Now what happens is, what I've seen while reviewing papers is that uh, people tend to copy paste the whole analysis. So analysis is available, the code for analysis is available online, it's very easy to find. But the issue arises if your data is not in the correct form, and then you get errors and you are not able to proceed with the analysis. So that is why understanding this basic of data types, data structures is absolutely essential before you can start doing any type of tests in R, or carrying out any data analysis as such in R. Okay, so you have numbers, character, and we'll look at all these data types and structures in today's session. Okay. Now, what are the strengths of R? R is first of all free, as I said, and open source. So anyone can download it, anyone can use it. The second advantage is that it has a very strong user community, meaning tomorrow while carrying out your own analysis, you get stuck in some place. Okay, you are not able to figure out how to proceed. If you just search for that problem, I am certain that 99% of the time you will be able to find a solution for it, because someone already has answered it. Some expert has already answered it. Okay, so that is one big advantage of R. So there are hardly any places where you will be stuck. There will always be solutions available online. Okay. And nowadays, R is not restricted to your basic statistics that you can think of, like say T tests or Z tests. Nowadays, R is used in even AI or machine learning. So you have packages to handle machine learning algorithms also, right? And as I said, R is excellent as far as data visualizations go. So you can produce very beautiful graphs in R. But at the same time, R is a programming language, so it's not that user friendly. You don't have much graphical user interface. So point and click functionality is not there. Okay? And since it's a programming language, it has a steep learning curve, meaning it takes time to understand the basics of R. You need to get used to writing codes in R. Okay, but once you get used to it, it becomes very efficient and easy. The third issue is not a disadvantage as such, but the issue is that since it's free, people come up with different solutions. So there is no one optimum solution. You can address the same problem in 10 different ways. So for beginners, it becomes a little confusing, because how to troubleshoot a problem if you have 10 solutions, which solution to use, which not to use. So that becomes a little confusing. Okay. And the last disadvantage of R is the type and the intensity of the analysis is limited by your RAM in your machine. So if you have a older machine having less RAM, complicated analysis with large data sets you cannot do, because as I said, R utilizes your RAM for storing results or storing data. So if that data is too big, then R or the machine will get hung up and you have to restart your machine. So that is one disadvantage of using R on the local machine, okay, on your machine. If you run this in cloud, then it's a different story. I'm certain that all of you must have installed this R Studio, R and R Studio. So R Studio is a powerful tool to use R. Okay, so you have something called as R console. Okay, and you have R Studio. So we are going to use R Studio. All right, we are not going to use R console. Right. So R Studio can be thought of as a platform to run your R code. Okay? And this is also free. So R Studio, you must have downloaded it on your system and installed it. So the basic version is free for everyone. All right. So what are the components of this R Studio? So on the top left hand side is something called as the terminal, where you basically write your scripts or load your scripts. All right. Whatever you load and run, the answer you'll get in the console on the bottom left hand side. Okay. All the data or all the variables that you create, you will be able to see on the top right hand side in the environment. Okay. And on the bottom right hand side, you will be able to view all the plots or to look for help. All right. So this becomes a very easy tool for beginners, especially beginners, because using R console directly for a beginner might be a little challenging, simply because R Studio offers certain shortcuts, and we'll see some of them when we are actually doing the hands-on session. Okay. Now there are some tips before we actually start. You have to be careful when you name an object. Okay? Don't name an object XYZ or X or Y. Always name it so that it has certain meaning. But at the same time, you have to avoid names which are already functions in R. Meaning, there is a function in R called as mean, which calculates the average of the data. So you should not name your object as mean, because then it gets confusing. Okay? Object names, okay, your names of the variable names cannot start with a number. R will give an error if you start your object name with a number. Okay, as in the digits. You can spell it out as ONE as 1, that is fine. But putting 1 there is going to give you an error. All right. As far as possible, don't use special characters. Okay. And whenever you are naming your data with more than one word, you have to use underscore or a dot sign to fill the spaces, because R is not good with spaces. If you leave the space as is, R is going to give an error. So always put something to fill in the space. Okay. R is case sensitive, meaning suppose you are interested in finding out the mean, and instead of small m, you use a capital M. If you do that, then it's going to throw an error, because it doesn't understand what capital MEAN is. It's only meant to know small MEA. That is why it's case sensitive. Okay. And last tip is always comment on your code. What is that code doing? What is the purpose of that code? If you don't do that, suppose you write a script, okay, of 500 lines. You don't look at that script for 6 months, and you come back to that script after 6 months, and you try to understand what you have done. If you have not commented on that code or that script, it will be very hard to get what you had done 6 months back, even if you have written the script by yourself. Always comment on your codes. Now, a small part of data in biology. So what does biological data entail? You are used, or most of you are used to having or seeing data as rows and columns. Yeah. So you use Excel to fill your data sets. But now these data have increased or gone beyond your conventional rows and columns. So your data could be text-based. So the people who are working with sequences are basically text or string-based data. You can have data as GIS values or shape files or raster files. Okay, so those data are not in your rows and columns. Your data could be completely audio visual. So your data could be entirely made up of videos or images. All of these data are R can handle. All right, you can analyze any type of data in R. But at the end of the day, you should understand or remember that R is a tool, right? And it's always going to give you some information based on the data that we provide. So, as a researcher, it's up to you to be very honest and objective while generating this data and analyzing this data. Okay. So, R will give you some result, but you have to be very honest and objective. All right. So, that was just a very brief presentation about R. Okay. So what I want all you to do is open your R Studio. So all of you open your R Studio. And it's R Studio, all right, not R console. It has to be R Studio. And in the meanwhile, if you have any questions, you can ask.
Instead, I do open
Let me know if you have any difficulties opening R Studio. So this is how your R Studio should look like.
Any of you have doubts in between? Use the mic and ask. யாராவது நேற்றே அனுப்பல காலையில் பண்ணிக்கலாம்.
Was everyone able to open it?
Yes, sir.
Yes. Okay. So now go to this file option, drop down menu. You see this file? Click this drop down menu. There you will see a third option called as open file. Okay, you have to click on that open file. Now you will be able to get a dialog box like this. Okay, now you have to go to the place where you saved your today's R file. Okay, and open the R file. This should be your data R file that you have downloaded. It might be in different folders, okay, on different machines. So just open this. Were you able to open it? Any issues with opening the R file? Should we continue? Please do let me know if you are facing any problems, okay?
Data download பண்ணீங்களா? Data.
Sir?
Should we continue?
Yes, sir.
Was everyone able to open the R Studio and the file?
Yeah, they are on the process of doing. So they should be done in 5 minutes.
Very open.
Okay, so should we start or should I give you a minute or two still?
Give us 2 minutes. 2 minutes.
Okay.
You open the file.
No.
And in the meanwhile, again, if you have any questions, you can ask.
That thing open, right? Sit together.
Hello, sir.
Yeah.
Sir, how we can download the package and how we can install it, like, and how we can find if there is any source like R or something. He will say.
We'll see tomorrow how to install packages. Today we'll just look at the different data types and data structures. Okay, so that is the absolute basic of R.
Right.
Should we start?
Yes, sir. Yes, sir.
Okay. So you must be seeing this file, yeah, on your screen.
Yes.
So if you look at these parts, all right, the green parts on my machine, it's looking green. Okay, it might be that it's of some other color on your machine. That is not important. But do you see this, all this part with hashtags? Yeah, all this. So this is what I meant by commenting. So people also come up with like very exquisite designs. Okay, so you can also have designs in your R file, but that is besides the point. So if you look at this particular part of code that I've highlighted, now what this does is it basically adds text information to your code. It gives context to the code that you are writing. And this might seem pretty trivial right now, looking at these codes, because these are very basic. But tomorrow, once you are used to doing analysis in R, if you don't comment like this on the code, you yourself will find it difficult to understand what you have done after, say, a few months' time. So it's a very good practice that you always comment on your code. So what is that code doing? What is the purpose of that code? What are the critical steps, if any, in that code? So you can just put a hashtag. Okay. So you can just put a hashtag like this and start writing whatever you want to write. But make sure that you first put a hashtag, all right? If you don't, and if you write, then R is not going to understand what this is. And it might throw an error also. Okay. So always remember to put a hashtag. Okay. So the first thing that we'll do is we'll define a variable in R. Okay. So this variable, the name of this variable is my variable. Okay. And what we are doing is we are assigning it the value 19. Okay. So whenever you want to run a piece of code in R, you can either press Control Enter or you can press this run button over at the top. Okay, so you can click on the code and just press run. Whenever you run the code successfully, if you are creating a variable, you'll see an environment that variable details will be here, will be loaded. Okay, so that is one way of knowing that you have created a variable. But if you notice, this is just creating a variable, Suppose I'm interested in knowing what data is there in this variable. I have to call out the name of that variable again, meaning I have to type that name again. Okay, and that is why I have written this name here again. So now what we have done is we have assigned the value 19 to this variable, and now we want to check whether this variable actually contains the value 19. So I type the name again and run the command, and then you will see in the console that actually the variable has this value 19. All right, is this clear? Any difficulties?
No, sir, it's not.
Okay, now you can use equal to sign also instead of this assignment operator. More or less it does the same thing, but since you are starting out with R, make or uh, make a habit of using this assignment operator, because after some period of time you will find out, or you will come to this difference, the subtle difference of equal to and assign operator in R, right? So that is something I won't discuss right now, but it's a good practice to use the assignment operator right from the start. But don't make a habit of using a equal to sign. Okay. Now that you know how to define a variable, now we'll look at the different data types. And why are these data types very important? Suppose you are importing a data set, yeah, whatever data set you have created, or you have done an experiment, entered your data in Excel, and now you want to analyze it. What happens is, in many cases, when you import your data from Excel into R, the numbers in that data sheet automatically get converted into text. Okay, and if that happens, no matter how hard you try, you won't be able to carry out any mathematical operations. Why? Because they are not treated as numbers by R. Okay, so you should understand the different data types in R. That is the reason you should understand the data types. The first data type, or the first two types of data we'll look at, are number based data. Okay, so what we are doing here is we are creating a variable A or object A, and we are assigning it the value of 5.688. Okay, so if you run this command, we'll be creating a object A. Now again, to know what value we have given to this particular A variable, you have to type in the name again and run the command, so that you know, okay, R has actually taken the value of 5.688 and assigned it to A. Okay. Now to get the type of data that A has, you use this function in R called as class. Okay. Class basically gives you the data type. And as input for this function, all you have to provide is the name of the object. So if you run this command, you will see that it is of class numeric, meaning a number. Okay. Is this part clear? So you use this function called as class to obtain the data type of that object or variable. Okay. Now there is a difference. There are two different types of numbers that are, or actually it's three. For us, it will be two for now. They are either numbers with decimals or they are whole numbers. Okay. Now, in many cases, this doesn't matter whether you have whole numbers or decimals. But in certain instances, this can be complete. This can mean completely different things. So, can you think of an example where you would be using only whole numbers or integers, and you would not even think of having a decimal value there? Can anyone think of any example like that where you only have whole numbers as the data? Can anyone tell me or give an example? Yeah. Any example will do, where the data is of only whole numbers.
Roll numbers or rank list.
Exactly. Your roll number. Can roll numbers be 45.3 or 45.253? No. Your roll numbers are always whole numbers. Or your ranks. You don't have a rank called or rank designated 1.245, right? You have either rank 1 or rank 2. So in this instance, you can tell R that the numbers that you are entering are whole numbers and not decimals. Okay. So R treats such whole numbers as something called as integer. And the way to designate an integer is to write a capital L after the number. Okay, so if you run this command and you look at this object B, you will see that the value is 3. So there is no L. If you look at in the console, it still gives the value 3. But when you put a L, okay, when you are assigning this value to an object, when you put an L, R knows it that you are intending that to be an integer and not a decimal. Okay. So if you look at the class of this object B, if you run this command, you will see now that it's not numeric, it's integer. Is this difference clear? So there is a subtle difference. Okay. In many instances, it won't matter whether you have whole numbers or you have decimals. But in instances like roll numbers or ranks, there having an integer and having a decimal number are two completely different things. You can't have decimal numbers in certain instances. Okay. Is this difference clear? So R also handles this difference properly. Okay. Is this part clear? Any difficulty with this?
But when we run this class thing, it shows execution error.
Have you run it properly? So you have to first assign the value A or assign the value B. Okay. So run first line of code, then run the second line of code, and then run the third line of code. If you have not assigned the value 3L to B, then there won't be any B object. So there is no question of having a class of an object that has not been defined. So one advice to you, never ever skip a step while you are running your code. Because in hurry, what you tend to do is you tend to write different bunch of codes and you tend to ignore the above steps and immediately run the latter part of the code. So if the latter part of the code contains objects which you need to create, if you don't create them, R is going to give an error because R won't be able to find the objects only. Okay. So run all and individual lines of codes properly. So if you run this and then press this, then you will get integer. Are you able to get it now?
Yeah.
Okay. Is this part clear? So difference between the number, a decimal number and an integer. Any questions?
No questions.
Okay. So the third data type, which is very commonly used in R, is of the type of character, which is text-based data. Okay. Any text-based data that you can think of will be considered as character data in R. So do you notice a difference here? There is some difference here. So say you compare B or A to C. What is the difference that you see? First of all, do you notice a difference? Look at object A and look at object C. What is the difference that you can spot?
It's a word, it's a number.
But what is so special about that?
So one is getting to quotes.
Exactly. So do you see the quotes there? So for a character data, there are always given within double or single quotes. Always. Whenever you want to use or input character data, or assign character data, you have to give double or single quotes. Okay, so if you run this command and look at our object C, you will see that R has created this C object with and assigned it with zoology as the word. Okay, now this is where the interesting part happens. Now if you notice this is a number, right, this is a number, but it's within double quotes. So if you run this command and look at the class of this object E, it's still character. So do you now, can you recollect the issue that I told you about? So when you import your data in R, something happens and R basically inputs your data as a character data instead of numeric data. And then know how hard you try to analyze this character data, you won't be able to do it because R doesn't recognize this as a number. Okay, and this happens quite commonly. It's not a rare thing. It happens quite commonly. But now you know the reason why this is happening. Okay, and you will be able to rectify it. And how to rectify it, we'll see it tomorrow. So you can convert one type of data into another type of data within R itself. Okay, that is something we'll see tomorrow. But is this distinction clear? So you can have character data of numbers also if you put them within quotes. Okay, is this part clear? Any difficulties with this? Okay. The fourth most commonly used data type in R is called as logical or Boolean values. So Boolean values are only of two types. Either they are true or they are false. All right. So right now, just run this D command. Okay, I'll tell you what that C is in just a few minutes. Just run this command and look at the class of this particular D. You'll see that R has assigned the data type logical to it. Now, these values or these types of data come in handy, especially if you are doing some conditional operations, meaning you want to select a particular data based on certain condition. In that instance or in that case, you can use such Boolean values. Many functions, okay, many functions in their arguments. So we looked at what arguments are, right? In their arguments have Boolean values as inputs. So whether some condition is true or whether some condition is false, that has to be an input. So based on that true or false condition, there will be different calculations in the body of the function. So they are quite important. So logical values are very important and very commonly used in R. Okay, but they only have two values, either true or false. Okay, now are these the only data types in R? The answer is no. There are many data types in R, but these four are the most commonly used. Okay, so 90% of the time, or at least 3-4% of the time, you will be dealing with these four data types. Okay, is this part clear? Any difficulties with data types? Any questions?
Yes, sir.
Okay. Now, based on these data types, there are different data structures in R. Okay. These data structures use or make use of each data type in different combinations. Right. So again, there are many data structures in R. Okay, people actually define a specific data structure for their analysis also. So that also you can do once you are, say, very good in basics of R. You can define your own data structure, right? But there are five, or rather, there are four basic data structures that are very commonly used in R, and 90% of the functions that you will be using will have either of these data structures as input values. Okay, so the first and the most simple data structure is called the vector. Okay, so vector basically consists of a set of a single data type, meaning you can have a set of numbers, you can have a set of characters. Okay, so you can have a vector of numbers, you can have a vector of characters, you can have a vector of boolean. So this is a vector of boolean values. And how do you tell R that you want to create a vector? You use this function called as C, and C here stands for combine. So whenever you give this notation, okay, so this is telling R that you want to create a vector named vector1, and you want to assign it with these values. Okay, so if you want to give individual values more than one, you have to put a comma after every value. Okay, be it any data type. So if you run this command, R will create a vector called vector1 of 5 numbers. Yeah, and to see the contents of this vector, you type out the name, okay, and run the command. So you'll see the contents of this vector in the console. Okay, is this part clear? Any difficulties with this? Okay. You can also create a vector of character data. Yeah, so vector2 basically is a character vector of 3 values. And if you want to look at the contents, just type in the name of that vector. Okay, so you have to remember here 2 points. First, vectors are defined commonly by using this C function. And secondly, you can only have one type of data in a vector. You can't have more than one type. Okay, and just take a look. What happens, suppose, if we try to define a vector of more than one data type? Suppose you are intending this vector to be numeric, yeah, but you add, say, a character data here. Okay. Now again, yeah. So before that, so if you want to look at the class of that vector, you use the function class. Like just like you saw for the data types, you can use this function for data structures also. So this will tell you that this is a numeric vector. Okay. Now, suppose I create this vector. Okay, this is vector 3. I am intending this vector to be numeric. But let's see what R has assigned this vector as. You notice the class? It's not numeric, it's character. Why did this happen? Because you put a character between numbers. So R doesn't know how to handle it. So it simply assigns it a data type of its choosing. And now suppose you want to use this vector for mathematical operations, you won't be able to do any operations because of this mistake. Okay, and that is why vector can only have a single type of data. All right. Now, in addition to the data types, data structures also have a little bit more complexity. So you can get the length of a vector, meaning you can also get to know how many elements there are in a vector by using this function called as length. Okay, and in parentheses, the argument that this length vector length function takes is the name of the vector that you have created, any name that you have given. Okay, so here if we check the length of vector 1, we'll see that the length is 5. Why? Because there are 5 elements: 1, 2, 3, 4, and 5. Okay, is this part clear? Any questions or any difficulties with this?
No, sir, it's clear.
So the most, as I said, important part of the vector data type is that it should only have one type of data. And if your vectors are numeric, you can carry out any mathematical operation on it. So what this does is, if you run this command, it basically adds this value 6 to each element of the vector. So 1 plus 6 is 7, 2 plus 6 is 8, 3 plus 6 is 9, and so on. And this is just a simple example. Okay, you can have like a really complicated mathematical operation also using a vector. Just making sure that that vector is numeric. Okay. Now, as I said, with a vector, you have certain added complexity than the data type. Meaning, each of this vector, element of this vector, has a position. Okay, so the first position is held by 1. The second position is held by 2. And how do you know first position is held by 1? Can you see this 1 in the square bracket? Yeah. So this is telling you that the first position in this vector is of number 1. For that matter, if you look at vector 2 also, first position of vector 2 is held by alphabet A. And why is this important? Because you can subset your vector based on these positions. Meaning, suppose I'm interested only in the second element of this vector. Okay, I'm not interested in the rest of the values. What I can do is, I can type the name of this vector and within square brackets. So whenever you are giving square brackets in R, R assumes that you are going to subset your data. Okay. Anytime you use a square bracket, it tells R that you want to extract out a certain part of that data set. So here what I'm telling R is, from vector 1, select the second element. Okay, and if you run this command, you will see that the second position here is number 2. Is this part clear? Any questions? Maybe you can take a minute to go over all the vector part, and then we can continue. Okay, so just look at all the operations that we did for the vector, and we can continue with the second type of data structure. Yeah, again, in the meanwhile, if you have any difficulties, please ask. Should we continue? Any problems? Any issues? Please don't hesitate to ask, okay? Even if it's a very simple part on your side, you can ask me. Not an issue. Okay. Moving on. Now, if you look at the second type of data structure, now the complexity increases a bit. So you had only a set of elements in a vector. In a matrix, you have an arrangement of rows and columns. Okay. So the complexity increases. And by complexity, there is an advantage in that, being more data can be stored. So vector can only store a data in a single set, but in a matrix you can store it as a combination of rows and columns. Okay, so you can just run this command. This is basically a command to generate a matrix, okay, in R. So you need not worry about it, simply because your data set is something that you will be importing from Excel or from a text file. This only is useful for intermediate or advanced users, because if your data or if your research involves simulating data, if it's completely dry lab based and your data or your research question involves only data simulations, then all this becomes important. This is basically telling R to generate a matrix, okay, nothing else. But what is important here is if you run this line of code and if you look at your matrix, so just look at what a underscore matrix is. So by typing the name and running the command, you will see that we have created a matrix of 3 columns and 8 rows. Okay, so you have 3 columns, 1, 2, and 3, and you have 8 rows, 1, 2, 8. Yeah. Now carefully look at the column headings and the row headings. In vectors, you just had one number, right? So if you look at our vector, you just had one number, correct? Here, the situation is different. Okay, so what does this mean? 1 comma basically means the first row. First row. So a matrix is denoted by rows, comma, columns. So the first number is of the rows, followed by a comma, followed by the second number, which is of the column, always in R. So whenever I mean 1 comma, I mean the first row. Similarly, when I say comma 1, I mean the first column, or comma 2, I mean the second column. Okay, always. So this is how you can tell R how to subset it. Now to understand the class, you use the function class, just like a vector. Here you will see 2 answers. You will see something called as a matrix and something called as an array. You can ignore this part for the time being. Okay? Don't worry about this. It does give you an answer that it is a matrix. Okay. If right now, as I said, don't worry about this array part. The length of the matrix gives you the total number of elements in that particular matrix. How many elements do you think there are here?
24.
Don't run this command and tell me it's 24. Why is it 24?
That's the question. You've given like from 22 to 43.
That is one part. The thing is, how do you basically say that it's 24? Is that one part of it is that you have 24 elements that are categorized into.
E column and 8 rows.
How do you find out the total number of elements? You just multiply them, right?
Yeah.
Correct. So that gives you the length. That gives you the total number of elements in this particular matrix. And the function to do that in R is length. If you run this command, you'll see that the length is 24. Okay. In vector, what was it? It was just the number of elements in that set. But here it's the combination of rows and columns. So do you now appreciate the complexity? So it's getting a little bit complex. And complexity, as I said, means storing more data. So you can store more data in a matrix than you can in a vector. Okay. Now you can also check the dimensions of the matrix. Dimensions here meaning the number of rows and the number of columns. Okay, using this function called as DIM. and the argument that it takes is the name of the matrix. Okay, is this part clear? As I said, for now you can ignore this part. This is just creating a matrix for your understanding. You will be working with your data sets that you will be creating for your experiments, from your experiments. Okay. Is this part clear? Any difficulties with this? Now, if you remember, I talked about this particular column one, comma one, comma. This is how you can access specific elements of a matrix. So for a vector, we saw that you do it either this way. This basically means a sequence. Okay, this basically means select the first three positions, not two, it's three here. Select the first three positions in vector 2, or select the second position in vector 2. In a matrix, since the data is a little complex, you have rows and columns, you can specify which row and which column do you want to extract out, meaning the exact value in that cell. So here it's telling extract out the value in the second row, third column. So if you run this command, you'll see that 37 value has been extracted. Second row, third column. Okay, and again in square brackets. Suppose you are interested in getting all the elements of the second row. This is how you write it. This tells R that you want the entire contents of the second row. 2 comma. What is 2 comma? This is 2 comma. Correct? Right? Similarly, if you are interested in finding out the values of a specific column, what will this do?
Third column.
Okay, yeah. So you get it, right? So this will basically extract out all the elements from the third column. So you have two choices. You can either select specific cells, or you can select specific rows or columns. Up to you how to use them. Now you can also convert your columns to rows and rows to columns by transposing the matrix. The function to use for that in R is just T. Okay, and the input data that it takes is the matrix. So if you run this command, you will see that your rows have become columns and your columns have become rows. And this also comes in handy in certain instances for calculations. Okay. Similar to a vector, if your matrix is numeric, you can perform any mathematical operations on it. And that mathematical operations will be performed cell-wise. So this basically will subtract the value 5 from each of the element, each of the cell. Okay, and here you can have a very complicated calculations also. So it's not necessary to have these simple operations. All right, is this part clear? Any difficulties with this? Now what I would suggest you do is, after this session, you can search for what arrays are. Arrays are basically multi-dimensional matrices, meaning this is just one matrix, right? So this is a unidimensional array, meaning it has just one dimension. You can have multi-dimensional matrices like this. So imagine a square, right? A square is your matrix, and a cube is an array. Okay, so matrix has only one face where you have rows and columns. A cube will have how many faces? How many faces does a cube have? Anyone? 6. Okay, so you can think of storing your information in multiple dimensions. And I specifically am not spending time on arrays because they are quite complex to understand. But if you are still interested in knowing what arrays are, you can go on YouTube and search for arrays in R. So they have really beautiful videos, a few beautiful videos where they actually tell you the difference between an array and a matrix. Okay, but arrays are not that commonly used in operations in the regular statistical analysis. Okay, you will be dealing either with matrices or something called as data frames. Okay, so need not worry too much about arrays. But if you are interested, as I said, after the session, you can just go online and look for them. Okay. Is this part clear? What matrices are? Any difficulties? Any questions? No question? Okay. Now, similar to a vector, a matrix can only have one type of data. So you can have matrices of characters, you can have matrices of numbers, you can have matrices of Boolean values. So that still is a limitation for data analysis. Okay, why? Because if you look at many of our biological data sets, yeah, they are not only restricted to numbers. Okay, you have sometimes text along with your numerical data. You have sometimes dates along with your numerical data. So matrix can't handle that. So then there is a data structure specifically designed to handle such data. And that structure is called as a data frame. So a data frame you can think of as the conventional data set that you enter in Excel in rows and columns with column names, row names. That in R is called as a data frame. So, okay, and these are the most commonly used data structure in many biological data sets. And if you look at the functions in packages for life sciences, you'll see that the input data that they take are these data frames. Most of them. Some of them do take matrices. Very few of them take vectors. But arrays are something that are hardly used in conventional statistics. Okay. Again, similar to a matrix, what I've done is I have created a data frame here. So just run this command. You need not. So this is basically creating a data frame having 3 columns. Those columns are named here. This is A column, B column, and D column. So the names are A, B, and D. Okay. And if you look at the data frame, so you write the name of the data frame again, run this command. You'll see it does have a structure like a matrix, right? So you have rows and columns, but you have column names here, right? You have a data set which has one column as numbers, second column as characters, third column as Boolean values. So it can handle heterogeneous data. And that again adds to the complexity and data storage. So you can basically have more data here of different data types that you can't do in a matrix. Okay. Is this part clear? Any difficulties? Any questions? Okay. So to obtain the class of this particular A underscore data frame, again you use the function class. If you run this command, you see that R has identified this as a data dot frame or a data frame. Now, if you run the length function in for a data frame, you will see that it has come up with this 3 number. So unlike a matrix, which basically counts each and every element or giving you the length, a data frame's length is measured by the number of columns it has. So this data frame has 3 columns, and then this is something you will see as length. That is how a data frame has been written in R. So this is a difference, one more difference between the matrix and the data frame. Is this part clear? So if you notice, the length of a data frame is the number of columns, not the total number of elements. Right? But similar to a matrix, you can access the specific position or specific cell in a data frame using the same notation that you use for a matrix. And why is that? What could be the reason? Anyone? What could be the reason for this?
Maybe because of the square bracket.
Pardon?
Maybe because of the square bracket.
What? No. What could be the square bracket is just subsetting, but what could be the reason we are using the same notations as we used for a matrix? What is this notation? What does 2 and 3 mean?
Column and rows.
Right? Column and rows. A matrix also had column and rows, right? Correct? So a matrix also has columns and rows. I told you that a data frame has also columns and rows. Correct? So you can make use of this particular property and subset your data similar to a matrix. Okay, so this again is going to give you the element that is present in the second row, third column, which is false. Second row, third column. Right? Similarly, if you want to select out the specific contents of the second row, you run this command, you'll get this. Okay, this is the second row, sorry, not the first. But in addition, what you can do is a data frame has column names, which a matrix didn't have. Correct? So matrix did not have column names, but a data frame has column names. So what you can do is you can also make use of that. So suppose you are interested in selecting only the first and second column from that particular data. How would you do it? You basically specify a vector. So this is a vector, right? You remember our vector part? So this is a vector where I am specifying that I want A and B columns. And since they are column names, names are characters, I have put them in quotes. So this tells R that I want a subset of a data frame because you have square brackets. And what do you want in that subset? You want the A and B columns. But here, instead of the position, right, you are referring it by name, which you could not do in a matrix because the matrices or matrix did not have column names. A data frame, on the other hand, has column names. Okay, is this part clear? So if you run this command, you'll see that only A and B columns are selected. Is this clear? Any difficulties? Any questions? No questions? Okay. In addition, you can also access specific columns by using the $sign. So what I want all you to do is write the name of the data frame. And in RStudio, you have this autocomplete option also. So once you start writing the name, RStudio will already give you an option. What is the data frame that is there? You click on it. So it autofills it. Yeah. And just put a $sign after naming the data frame. R Studio will give you the options of the columns. Do you see this A, B, D? So these are the 3 columns. You can select any one of them. And if you run this command, it will only give you the contents of that column. Or suppose it's D. So this is another way that you can access the specific elements of the data frame or specific columns of the data frame. Yeah. So this was not available for a matrix, right? As I said, each of this data structure increases in complexity. So it can handle more complex data and it has more functionality. And that is why you will see data frame being the most commonly used data structure in many packages for analysis. Okay. So these are multiple ways of subsetting your data frame. Which one should you use? It's up to you. If you remember the talk that I gave you an hour back, there is no one optimal way of doing the analysis in R. If you feel that this is the best way to subset the data, go for it. If you feel this is the best way of subsetting the data, go for it. No reviewer or no examiner is going to question you why you did that way, so long as your answers are correct, your analysis is correct. Is this part clear? Any difficulties with this? Any questions? Any questions? No? So if you don't have any questions, then this is it for today's session. What I would advise you to do is you practice. So what you can do is change the name of the variable. Yeah. Change the name of the variable. Try to run it. Change the subsetting options parameters. See what happens. You will only learn by making mistakes. Okay. And it will just become easier if you keep on practicing. The main point here is you have to keep on practicing this. Just attending 1.5 hours of R session is not going to help you in learning R. You have to keep on practicing this. Okay. So yeah, if you have any questions, you can ask. And if you practice today and if you have questions for tomorrow, we can do that also. We can address those questions tomorrow also. No problem.
There are no more questions? No. Okay, thank you, sir. Thank you for this session. So they'll practice today and they'll let you know if they're having any problems in running these commands. So thank you once again. So
Sure, sir, sure. Thank you. Thank you, everyone. Good evening. Bye-bye.
Okay, let's break for tea. And then now you'll have to, after tea break, you'll have to go for geography for GIS.